Okay, so the next one we've got a trigonometric function. We've got sine over of 1 over x. So let's think about this. Let's look at 1 over x. We know that the limit as x approaches infinity of 1 over x is equal to 0, because we've already discussed this. And so, long story short, this is kind of asking us what the sine of 0 is. So if we think about it, we've got the limit as x approaches infinity of sine 0. Well, the sine of 0 is just 0. And so, ta-da, you're done. That is that. Even if it was a negative here, same result, right? Because we know this is negative and that approaches 0 as well. And so, ta-da, you're done. What if they had asked us what the limit as x approaches infinity of sine x is, though? Well, there you got problems, right? Because if I say your infinity is quadrillion pi over 2 or something, and I don't know what that is, but maybe it's 1. But you say, no, 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 wait, add 1 to that. And then, I add the 1 to it, and all of a sudden now I'm at -1. We can't come to a consensus because I'll go, oh, well, add 1 to that. And then you're back where I said. And so, because it oscillates so much at infinity, just like it does all the way at 0, this one does not exist, because we wouldn't be able to come up with a actual number, a specific one number that it's going to. It's going towards 1 at some points, it's going towards -1 at others, and it's going to all those points in between as well. So keep that in mind if you're trying to do limit of sine as it approaches infinity, or cosine for that matter. It does not exist unless you're actually going towards one specific number, kind of like we were doing here. You can kind of see it better, right? This is approaching 0, and so we can kind of see that that's approaching 0. If we did the limit of these two, limit as x approaches infinity of x to the third, well, if you plug infinity into that, you're simply going to get infinity. Why? Because you're going to get a positive times a positive times a positive. Those are all positives. And so it's just going to make it, whatever the number is, 3 times itself 3 times. And so it'll just go to infinity. If you do the limit as x approaches negative infinity of negative x to the third, you're going to get negative infinity, because negative times negative is positive times negative is negative. And therefore, you're going to have a negative infinitely large number. And then this one is a little bit tricky. Limit as x approaches infinity of x squared minus x. Now, you might be tempted to write something like limit as x approaches infinity of x squared minus limit as x approaches infinity of x, which is ultimately going to be infinity minus infinity, right? Wrong. You can't do this. Because we don't, the limit laws don't apply to infinity, because it's not an actual number. So you can't use the this infinity value with the limit laws. So, but what you can do, you have the limit as x approaches infinity of x squared minus x, and that's going to equal the limit as x approaches infinity of x times x minus 1. Well, that's a lot better, right? Because now you've got infinity times 1 less than infinity, which is just going to equal infinity. Right? So whatever number you choose, if you choose a quadrillion, you just choose 999. All right, I'm not going to say all of that, but I think you get the picture. You're just going to have a really big number minus a number that's just as big minus 1 of it. And so you can see straight away that that's infinitely big, large. And then finally, we've got let f be a function defined on some interval a to infinity, then the limit as x approaches infinity of f of x is equal to L means that for every epsilon greater than 0, there is a corresponding number n such that if x is larger than n, then f of x minus L is less than epsilon. This is back to our precise definitions of a limit, but now for the infinite case. So I don't think you'll see too much of this. However, I do want you to know it exists. And it might be kind of hard to draw a picture of this, right, if it's a particularly big thing, but maybe not. It would just be hard to visualize it because remember, you're going towards infinity, and so if I draw the graph, you've got some n, and then you've also got some e epsilon. That's the ugliest epsilon, and you've got some n, and it's contained inside that. It contains all the values. So long as you choose n sufficiently large enough to contain all of them. So I hope you guys are learning. Make sure you get ready. You have a quiz after this section, so after these videos and these homework sections. And then we are on to the next section. Thank you guys for watching.